All right, ready to dive into some AI and machine learning.
Let's do it.
Sounds good. For this deep dive, we'll be looking at AI and machine learning for coders.
Great book.
Yeah, looks like it'll give us some practical skills to build some real AI projects, without needing to go back to school for a PhD or anything like that.
That's one of the things I really liked about it, actually. It really tackles, the limits of traditional programming.
Okay, so how so?
Well, it starts off with this question, how would you even code an activity detector? Using traditional rules-based programming.
Interesting. Okay, so let's say we want to, track if someone's walking or running or cycling. I guess I could write some code, right, that uses speed thresholds. Like, if the speed is below this value, they're walking. If it's above that, they're running, and so on.
Yeah, you could, but that's where things get kind of tricky.
I was kind of waiting for the but.
Right. So, what if you wanted to detect something like golfing?
Golfing.
Yeah. There's, all these stop-and-go movements, walking different distances, swinging.
Well, it's not just, a constant speed thing.
Exactly. And that's where traditional programming kind of hits a wall.
So that's where machine learning steps in, I'm guessing.
Exactly.
Instead of these crazy rule books, we just let the machine figure it out from the data.
Exactly. Imagine, instead of giving the computer instructions, you're feeding it data. Tons of data, like someone's movements, speed, heart rate, maybe even GPS, and you just label each set, right? Walking, running, golfing, and so on.
So we're kind of teaching it by example, like showing a kid pictures saying, this is a cat, this is a dog, and they start to figure out the patterns.
Right. It's all about learning from data, not instructions.
Pretty neat. But how do we actually make these machine learning models?
Well, the book talks a lot about this platform called TensorFlow.
Yeah, I was wondering about that. Sounds important.
It's central. It's like a massive toolkit, packed with algorithms and patterns. It handles all the crazy math behind machine learning so you can focus on building your app.
So it's kind of like a super-powered library of machine learning building blocks?
Yeah.
Okay, but doesn't that oversimplify things? Do we really understand what's going on under the hood?
That's a really good point. But TensorFlow does let you peek under the hood.
Okay.
It's a good mix of accessible and in-depth, and you can use it for pretty much anything.
Really?
Yeah, personal projects to big research stuff.
Nice. And the book goes into some practical stuff, right? Computer vision, which always sounded so sci-fi to me, but now it seems more, I don't know, doable.
Oh, yeah, it is. Computer vision is all about teaching computers to see and interpret like we do.
Yeah.
And the book uses this really cool example, the Fashion MST dataset.
Fashion MST dataset.
Yeah, so it's imagine a massive digital fashion show, but for computers. And it's thousands of images of clothes, shirts, trousers, dresses. Each image is simplified, just like a grid of pixels.
Oh, okay, I get it. So a black and white version of those clothing images you see online.
Exactly.
So then how does TensorFlow help us teach a computer what's what in these images?
Well, then we get to use neural networks. Imagine a network of nodes, kind of like a brain, right?
Like a digital brain.
Yeah. And each one receives input, like the pixels from the image.
Oh, so each pixel becomes data for the network.
Yeah. Then it performs some calculations and passes the output to other nodes.
Calculations? What kind of calculations?
Well, each node is basically analyzing the input and learning to detect certain features like edges, corners, textures.
Ah, interesting.
And they do this by adjusting their weights and biases.
Weights and biases, yeah, okay. Remember those words. Can you refresh my memory?
Yeah, so weights are kind of how important an input is. So a higher weight means that input has more influence. And then biases are adjustments to the output.
Adjustments.
Yeah, so the network learns which features are most important.
Oh, so it's fine-tuning its perception to figure out what's what.
Right.
But I bet it's not that straightforward.
You're right. There are some challenges. What happens when our model, trained on these simple images, suddenly has to deal with a real-world photo?
Yeah, wouldn't it, freak out? A T-shirt in a photo is way different from a simplified grid.
Exactly. The book even mentions this kind of funny example where a model misclassified a woman as a horse.
A woman as a horse.
Oh, no.
Yeah, it just shows that training on limited data can be a problem.
So how do we stop our AI from making, those kinds of mistakes?
Well, TensorFlow to the rescue again.
Of course.
It's got this thing called image augmentation.
Image augmentation, like adding stuff to the images?
No, it's more like we're making new training data.
Yeah.
Like on the fly, by changing existing images, rotating them, zooming, flipping, and so on. Oh, so it's like showing the model all kinds of variations.
Yeah, so it learns to recognize a t-shirt in any context.
Clever.
But then there's another level of complexity.
Oh, no.
Yeah, convolutional neural networks.
CNNs. Are those like super neural networks just for images?
Yeah, you could say that. So imagine, like, sliding a magnifying glass over an image.
Okay.
And you focus on each section, analyzing for features like edges, corners, and imagine multiple filters working together.
So like a team of detectives.
Yeah.
What happens next?
Well, CNNs use many layers of these filters, and the output from one layer becomes the input for the next one.
Wow.
So you start with simple stuff like lines and edges, and then combine those into shapes and so on.
So it's like building up an understanding step by step.
Exactly.
And in our horse or human example, like early layers might be picking up edges, then maybe shapes, then the whole form.
Yeah. Breaking down image recognition step by step.
This is amazing. We've gone from neural networks to these CNN powerhouses.
Yeah.
But image recognition is just one part, right? There's, natural language processing to teaching computers to understand human language. That's got to be even more complex.
It is. But let's give you a moment to digest all this. We'll come back to that in a bit.
Okay. I think my brain is rebooted. Back online. But teaching a computer to understand human language, it seems impossible, right?
It's definitely a challenge, that's for sure. But that's where natural language processing comes in, NLP.
NLP, Brett.
And machine learning has helped us make some amazing progress.
I'm ready. Where do we even begin?
Well, it all starts with something called tokenization.
Tokenization.
Yeah, so we break down text,
Okay.
into words or units. Those are the tokens.
So it's like taking a sentence and chopping it up.
Exactly.
But words by themselves don't really have meaning, right? How do we get the computer to, like, understand the relationships between words? The whole meaning of a sentence.
That's where things get really interesting. We use something called embeddings. So imagine like this huge multidimensional space.
Okay.
And each word is a point in this space.
A point, okay.
And words with similar meanings are clustered together.
So it's kind of like a map of meaning.
Yeah, exactly. It is a map of meaning.
Can you give me an analogy? I'm a bit lost.
Sure. Think of a city map, right? Words with similar meanings are like buildings that are close to each other.
Okay, I see. So by looking at these word buildings, the computer can start to understand how they connect.
Yeah. And not just individual words, but how they work together in a sentence.
So the computer could then figure out synonyms or antonyms.
Exactly. And even more complex stuff. And, embeddings are used all the time, like for those recommendations you see online. People who bought this also bought that.
Oh, really?
Yeah, it's based on embeddings.
Wow. So they're already, like, shaping our online experiences.
Yeah. Pretty cool, right?
Yeah.
But let's not forget, we're talking about sequences of words. The order matters, right?
Man bites dog versus dog bites man. Totally different.
Right. And traditional neural networks, they don't really handle sequences well. They don't really care about the order.
Ah, that's where those RNNs come in.
Exactly. Recurrent neural networks, they're all about understanding sequences, not just in language, but anything that happens over time.
Wait, didn't we talk about those earlier? For images.
You're thinking of CNN.
CNNs, right.
Convolutional neural networks. Those are for images.
Right. So CNNs are like the spatial wizards and RNNs are the time travelers.
You got it. So how do RNNs handle this whole sequence thing? Well, they have these feedback loops.
Feedback loops, okay.
So they can remember information from previous steps. Like imagine reading a sentence and keeping each word in mind as you go.
So RNNs have a memory.
Yeah. But there is a catch.
Oh, boy. There's always a catch.
Simple RNNs, they struggle to remember over long sequences. But thankfully, there's a more advanced version, LSTMs.
LSTMs? That sounds complicated.
Long short-term memory networks. They're much better at remembering long-range stuff.
Okay, so they have, like, super memory.
Yeah, you could say that. They can selectively forget or remember information, like a filter.
So they can keep the important stuff and ditch the rest.
Right.
So with LSTMs, we're understanding how ideas connect in a text, not just words.
Exactly. And, the book takes it a step further. It talks about how we can use these language models to generate text.
Wait, so computers writing now? Didn't you say that was coming?
It might sound crazy, but it's quite logical. You train a model on tons of text, it learns the patterns, and then you give it a starting point.
Okay.
And it predicts the next word.
So it's like mimicking what it's learned.
Exactly. Like the book talks about a model trained on Irish folk songs. It created new verses.
No way.
Yeah, and another one trained on Shakespeare. It generated like Shakespearean dialogue.
That is both fascinating and a little scary. Are computers going to replace writers now?
That's a big question. But these models are tools, you know?
Okay.
They can help with creative writing, maybe give new ideas, but they're not going to replace human creativity.
So more like digital muses.
That's a great way to put it, and it's a key takeaway from the book. These AI and machine learning tools, they're super powerful.
Right.
But it's up to us how we use them.
It's a lot of responsibility, huh?
It is, and it's exciting. We get to shape the future of AI and language.
I agree. It's definitely been a lot to take in. Neural networks, embeddings, RNNs, LSTM.
I know, right? It's a lot. But we're not done yet. There's one more area we got to explore: how these techniques are being used to analyze data and predict future trends.
Oh, you mean like predicting the weather or the stock market?
Exactly.
That sounds incredibly useful, but also like super complicated.
It is. But that's a story for the final part of our deep dive.
Okay, I'm back. Ready to tackle this predicting the future thing.
Mm-hmm.
Sounds a bit like fortune telling, though.
It can feel that way. But that's what makes it fun, right? Today, we're diving into how coders can actually use AI for, analyzing time series data and forecasting trends.
Time series data. I'm not sure I'm following.
Right. So it's basically a series of data points collected over time.
So like anything with a timestamp.
Yeah, but it's more than that. It's like a sequence of snapshots, right? Each one capturing a specific moment. Like, think of daily temperature readings, stock prices over a month, website traffic over a year, anything that changes over time.
Okay, so it's not just that it has a time. It's that the order and like the relationship between those points over time that matters.
Exactly. And we want to find those patterns, those trends, so we can predict what happens next.
Predict the future. Easy, right?
If only. There's so many factors that can, mess things up.
I was going to say, there's got to be more to it.
Oh, yeah. For example, a lot of time series have trends, meaning they go up or down over time. Like, think of global temperature, right?
It's been going up, unfortunately.
Exactly, a clear upward trend. But then you've got seasonality, too, like recurring patterns that happen, regularly. Ice cream sales, they peak in the summer, then drop in the winter.
Right, makes sense. So it's not just the overall trend. What else?
Then there's autocorrelation, where past values directly affect future ones. Think of a website suddenly gets tons of traffic because of a marketing campaign.
Oh, okay. So even after the campaign ends, the traffic might still be higher than usual because of that initial bump.
Yeah. And on top of all that, there's noise. Just random fluctuations that make it hard to see the real patterns.
Wow, it's a mess. Trends, seasonality, autocorrelation, noise. How do we even start making predictions with all that going on?
Well, the book suggests starting simple, just to get a baseline. There's this thing called naive forecasting.
Naive. Sounds a little basic.
It is. You just assume the next value will be the same as the current one. Like tomorrow's temperature will be the same as today's.
I can already tell you that's wrong.
Yeah, usually it is. But it's a starting point. Then we can get a bit fancier with moving averages.
Moving averages. What are those?
So you smooth things out by averaging a bunch of previous values. Like take the average temperature over the last 3 days to predict tomorrow's.
So we're looking at a chunk of data, not just one point.
Okay.
Yeah, that makes more sense.
But even that has its limits, especially when things get, complex. That's where machine learning shines. It can deal with all those tricky bits better than traditional methods.
Time for the AI cavalry to arrive. But how do we prepare the data for machine learning?
We need to create what's called a windowed data set.
A windowed data set, like looking through a window at the data.
Kind of. Imagine sliding a window over the data, capturing, say, the past 7 data points. That becomes the input.
Okay, and what we're trying to predict is like the next point after the window.
Exactly. So we're showing the model, hey, based on this recent history, what comes next?
Cool. So what kind of neural networks can we use for this?
Well, the book looks at a few. DNNs, CNNs, even RNNs.
Wait, haven't we seen those before? Weren't those for images and language?
They were. But they're surprisingly versatile. DNNs are our general workhorses. CNNs can find local patterns within the window. And RNNs, well, they can remember those past dependencies.
So it's like we've got this AI toolbox and we can pick the right tool depending on the job, right?
Exactly. And the book really digs into, how to tune these models for best performance. It even talks about using AI to optimize AI.
Wait, what? Using AI to optimize AI.
Yeah, tools like Keras Tuner can help find the best settings for our models automatically.
That's wild. But even with all this, fancy tech, I guess it still comes down to understanding the data, right? Choosing the right tools, not just blindly applying algorithms.
Absolutely. It's all about understanding, experimenting, constantly refining.
Well, this has been a whirlwind. We've covered so much, from the limits of traditional programming to teaching computers to see, understand language, and even predict the future.
And AI and machine learning for coders has been our guide the whole way. A fantastic resource for anyone who wants to get their hands dirty with AI.
Couldn't have done it without this book.
Yeah.
It's really demystified some of these powerful techniques. And it's empowering, right? We can all be part of shaping this AI future.
Exactly.
So that wraps up our deep dive into AI and machine learning for coders. Hope you've enjoyed the ride. Keep learning, keep exploring, and keep coding.